Today we discuss about seventh group element. That seventh group element is nothing but halogen family. That means these seventh group elements are fluorine, chlorine, bromine, iodine, astatine. Of course, in every group, the first topic is electronic configuration. At the same time, the seventh group elements also first topic is electronic configuration. Now its electronic configuration is NH2NP5. Its electronic configuration is NH2NP5. That means N means number of cells, S means orbitals, 2 means electrons, N means number of cells, P means orbital, 5 means electrons. Now let us first electronic configuration. So what is its electronic configuration? Here first fluorine, chlorine, bromine, iodine, astatine. Now take again noble gas elements are helium, the next one neon, the next argon, then krypton, next one xenon. Helium is 2, neon 10, argon 18, krypton 36, xenon 54. Its electronic configuration is 2s2, 2p5. It is 3s2, 3p5. This one 3d10, 4s2, 4p5. This is 4d10, 5s2, 5p5. This is 4f14, 5d10, 6s2, 6p5. Which means here 2, 2, 4 plus 5. This is 9, 10, 12, 5, 17, 18, 28, 30, 35. This is 35. 36, 46, 48, 53. This is 53. 54, 78, 80, 86, 54, 68, 78, 80, 85. 85. Now this is the electronic configuration of what is seventh group elements. Now these seventh group elements are diatomic molecules. That's why it is denoted by X2. So these seventh group elements, IUPAC group. IUPAC group is 17. This seventh group element is also called sea salt element. That means they are available in salt. They are available in seawater. They are available in seawater. That's why this seventh group element is also called what about halogen family, and its IUPAC group is 17th group. Its IUPAC group is 17th group. Next one is oxidation state. Next topic is goes to oxidation states. What is the oxidation state? Now 7th group element oxidation, in every group oxidation states are depend upon electronic configuration. Of course, now 7th group element oxidation states are, its oxidation state is -1, -1, +1, +3, +5, +7. -1, +1, +3, +5, +7. Now these -1 are called common oxidation state. These common oxidation states are depend upon 0 group element electronic configuration. So what happened this one? So this is NH2, NP5. This is 7th group element. Now NH2, NP6. This is 0 group element. So what happened? 5 minus 6 equal to -1. These -1 are called common oxidation state. So other oxidation states are depend upon like this: NH2NP5, NH2NP5. This is in the ground state. This is in the ground state. In S how much? It contains 1 orbital, 2 electron, and P contain 3 orbitals, and 5 electrons. That's why one unpaired electron is there. That's why its oxidation state is +1. its oxidation state is +1. Now what happened in this next one, in the first excitation state. Now this is in the first excitation state. This lone pair enters in that side. What happened? It is S, it contain 1, 2, and P contain 3 orbitals, and 3 orbitals it contain 4 electrons, and D contain 5 orbitals and only 1 electrons. Only 1, 2, 3, 4, 5. Only 1 electrons. So it contains how much? 1, 2, 3. That's why it undergoes +3 oxidation state. Now what happened in the second next after this, in the second excitation state? In this second excitation state, this lone pair enters in this side. That means S it contain 1, 2, and P contain 3 orbitals. 1, 2, 1, 2, 3, and D contain 5 orbitals and only 2 electrons. There are 5 unpaired electrons. That's why its oxidation state is +5. Now in the third excitation state, this lone pair enters in that side. What happened? S it contain only 1 and P contain 3 orbitals, 3 electrons, and D contain 5 orbitals and 3 electrons. That's why there are 7 unpaired electrons. That's why its oxidation states are +7. Hence, 7th group element oxidation states are -1, -1, +1, +3, +5, +7. -1, +1, +3, +5, +7. This is oxidation states. So, what is the color compound of this noble gas elements? Color. So, its color compound of noble gas element is color. So, here fluorine is the pale yellow color. This fluorine is the pale yellow color. Chlorine is the greenish yellow color. Bromine is the red color. Iodine is the violet. Now, fluorine equal to, this is pale yellow in color. Pale yellow in color. And chlorine is greenish yellow. Chlorine is green yellow in color. Chlorine, bromine is red color. And then iodine is a violet color. So this is color of the noble gas elements. This is color of the fluorine, bromine, iodine. Here fluorine is the pale yellow color. Chlorine greenish yellow, bromine red color, iodine is the violet color. So this is what happened, color of the compound. The next one, what is the atomic radius? Next, here in the general property, atomic radius. What is the atomic radius? Here, atomic radius. Here, atomic radius means what? Atomic radius here. Now, top to bottom, from fluorine to iodine. That means from F2 to I2. Fluorine to iodine. From top to bottom, atomic number increases. From top to bottom, atomic number increases. When atomic number increases, atomic number increase. Atomic number from top to bottom, atomic number increases. Gradually, atomic weight also increases. That means the differentiating electrons enters into next to higher energy cell. This means next to higher energy cell, suggesting it has less predominant beyond of chlorine. So this is due to screening effect by inner d orbital. So this is what happened, atomic size or atomic radius. From what is the atomic radius? From top to bottom, atomic number increases. That means fluorine 9, 11, 17, 35, 53, 85. From top to bottom, atomic number increases. When atomic number increases, atomic weight also increases from top to bottom. That's why that means atomic number increases, atomic weight also increases from top to bottom. This means the differentiating electrons enters into next to higher energy cell. So this is fluorine, chlorine, bromine next to higher addition, suggesting it has less predominant beyond of chlorine. Suggesting it has less predominant beyond of chlorine. This is due to screening effect by inner d orbital. Inner d orbital. Next one, electronegativity. Electronegativity. What is the definition of electronegativity? The tendency of an atom to attract two shared pair of electrons. It is a diatomic molecule. It is a diatomic molecules are called diatomic or homoatomic are called electronegativity. So these halogens are high electronegativity. Halogens are high electronegativity. Halogens are high electronegativity. These halogens are fluorine, the next one chlorine, bromine, then iodine. Fluorine का electronegativity is 4.0, chlorine का 3.0, bromine is 2.8, iodine is 2.5. From top to bottom, electronegativity decreases. From top to bottom, electronegativity decreases. So this is electronegativity. What is electronegativity? The tendency of an atom to attract two shared pair of electrons. It is a diatomic molecules are called electronegativity. Halogens are high electronegativity nature. So from top to bottom, electronegativity decreases. That's why fluorine 4.0, chlorine 3.0, bromine 2.8. How to? I will give a good technique for this one. Fluorine, in the fluorine pronunciation F4, that's why 4.0. Chlorine, C letter A B C, that's why you have to remember 3. Bromine, B letter 2.8. B means 2, iodine is 2.5. The next one, after this one, physical state. Next one, physical state. What is the physical state? Here, physical state, the physical state, fluorine, chlorine is a gas. Fluorine and chlorine, these two are gases. These two are gases, fluorine, chlorine. Then bromine is the liquid. Bromine is the liquid. Iodine is the solid. Iodine is the solid. This is physical states of this one. Now after this physical states, next one, interhalogen compounds. Interhalogen compounds. These interhalogen compounds are basically 4 types. Interhalogen compound. Interhalogen. Interhalogen compound. Interhalogen compounds. These interhalogen compounds are basically 4 types. That is AX, AX3, AX5, AX7. AX. The next AX3. The next AX5. The next AX7. AX7. Interhalogen compounds are 4 types. That is AX, AX3, AX5, AX7. What is the meaning of this interhalogen compound? Interhalogen compound means the two halogen atom, they react with each other. The two halogen atom, they react with each other are called interhalogen compound. When the two halogen atom, they react with each other are called interhalogen compound. These are how many types? 4 types. AX, AX3, AX5, AX7. Sometimes it is also called XA, XA3, XA5, XA7. In some time it is also like this also. X, X1, X, X2, XX3, X, XX5 like that. So you have to remember any one, that is AX, AX3, AX5, AX7. Now let us we discuss one by one. Now what is the first AX? Now let us AX. Here AX nothing but X nothing but unpaired electrons. X nothing but unpaired electrons. A nothing but central. A nothing but what happened? Central. So what happened this one? Here for example the best example is CLF. AX nothing but the best example is CLF. The AX the best example is CLF. Which means what happened? That AX nothing but what happened? Here CLF, CLBr, CLI but not form FCl. It is not form. FCl is not form of AX type like that. Due to what happened? Fluorine is cannot central metal. Fluorine is cannot central metal due to fluorine is a small size. Fluorine is a small size and absence of d orbital, high electronegativity. That's why fluorine is cannot central. Fluorine is a cannot form central. Except to fluorine, other elements are from central. That's why what happened? CLF, CLBr, CLI, like that. So BRI, IBr, BRCl, but not from fluorine is central. So what happened? That seventh group element electronic configuration is NH2NP5. Of course, seventh group element electronic configuration is NH2NP5. So this formula is as it is written are called ground state. As it is written are called ground state. What happened? In the S it contain 1, 2. S it contain 1, 2 and P contain 3 orbitals and 7. 1, 2, 3, 4, 5. Okay, but here X means one unpaired electron is there. That's why it undergoes sp3 hybridization. It undergoes sp3 hybridization. How many sp3? Nothing but 4 sp3. Its shape of the molecule is linear. Its shape of the molecule is linear. How to draw the structure of linear? A is the central. It contains X. How many lone pair? 1, 2, 3. This is 1. This is 2. This is 3. So this is lone pair of electrons. Now this is AX3 type. AX type. Now what happened in the AX3 types? AX3 types. Now here AX3 type also same thing. Now AX3 type. AX3 type. So in this AX3 type. So first AX3 type, the best example is BRF3. The best example is or CLF3. CLF3. BRF3 like that. So what is this one? Its electronic configuration is NH2NP5. NH2NP5. This is in the ground state. This is in the ground state. Yes, it contains 1, 2 and P contain 3 orbitals and 5 electrons. 3 orbitals, 5 electrons. But here 3 fluorine is there, which means 3 unpaired electron will be takes place. So that is in the first excitation state. First excitation state. This lone pair enters in that side. Yes, it contains 1, 2 and P contain 3 orbitals and what happened? 4 electrons. And D contain 5 orbitals, only 1 unpaired electrons. Okay, 3 unpaired electron is there. That's why it undergoes sp3d hybridization. It undergoes sp3d. How many? 1, 3, 5 total. 5 sp3d hybrid orbital is formed. These 5 sp3d hybrid orbitals undergoes bent T-shaped. It undergoes bent T-shaped. It undergoes bent to T-shaped. How to draw the bent to T-shaped? This is what happened? A this central and it contains 3x. 1, 2, 3. This is 1, 2, 3. So and 2 paired electrons. This side 1 and this side 1. So this is bent to T shaped. The next one what happened? AX5 types. AX5 types. What is the meaning of this AX5 types? Now in this AX5, the best example is IF5. The best example is IF5. So the best example is IF5, nothing but what is the meaning of this one? The best example is IF5, nothing but first you have to write this NH2NP5. It is NH2NP5. NH2NP5. This is in the ground state. This is in the ground state. Now you have to write here already ground state we already there. First also, then already there. Then now you have to write directly second excitation state. What happened? This lone pair represent this side. So that's a what is this? Yes, it contain 1, 2. But P contain what happened? 3 orbitals and 3 electrons. Okay. Now D contain 5 orbitals. Only how much? 2 electrons. Only 2 electrons. So that's why what happened? It undergoes. That's why it undergoes sp3d. It undergoes sp3d2 hybridization. sp3d2. 2. So now we so what is the sp3d2? Its shape of the molecule is square planar. Its shape of the molecule is square pyramidal. Its shape of the molecule is square pyramidal. Its shape of the molecule is square pyramidal. So what is the square pyramidal? Here A is the central. It contains 4x. 1, 2, 3, 4. This is x, 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 x. 1 paired electrons. This is square pyramidal. Okay. Now after this square pyramidal, now AX 7 times. Now here we discuss in the AX 7 times. We discuss here. So what is AX 7 times? Now in this AX 7 type, the best example of AX 7 is IF7. The best example of AX7 is what happened? IF7. So that IF7 means here I is the central. That means so you have to write first what happened? Ground state. No problem. Then first. No problem. Second. Then write you have to directly third excitation state. What is the meaning of this third excitation state? Now in this third one. Now in the third excitation state, I am writing directly third excitation state. So that's why here. Now third excitation state. Yes, it contains how much? It contains only 1, 2. That means only 1. S contains only 1 orbital and 1 electron. So simply like this. S it contains only 1. P contains what happened? 3 orbital, 3 electrons only. 3 orbital, 3 electrons. And D contain 5 orbitals, only 3 electrons. 1, 2, 3, 4. 1, 2, 3. Okay. Now it undergoes sp3d3 hybridations. sp3d3. How much? 7. Its shape of the molecule is pentagonal bipyramidal. How to draw the pentagonal bipyramidal? So this is what happened? A central. It contains like this. This is penta. 1, 2, 3, 4, 5, 6, 7. These all contain what happened? X. These all contain X. This is pentagonal bipyramidal. This is so the group elements. Just what happened? First electronic configuration. What is its electronic configuration? Its electronic configuration is NH2NP5. Here elements are fluorine, chlorine, bromine, iodine, astatine. Now here that electronic configuration is NH2NP5, where N means number of cells, S means orbital, N means number of cells, P means orbital, 2 is electron, 5 also electrons. Now this seventh group element is also called halogen family. That means these are available in seawater. Its IUPAC group is 17 group elements. Next one, color of the compound. Here fluorine is the pale yellow color, chlorine is the green yellow color, bromine is the red color, iodine is the violet color. After that, oxidation state. What is the meaning of this oxidation state? So there are what are the color? We already there in the see what is the color? Pale yellow, green yellow, red and violet. Now oxidation states its oxidation states are -1, +1, +3, +5, +7. So simply these oxidation states -1 are called what happened? Common oxidation state. -1 are called common oxidation state. These common oxidation states are dependent upon zero group element electronic configuration. Of course, zero group element we already discussed. Its electronic configuration is NH2NP6. So that's why NH2NP5 minus NH2NP6. Remove that to get what happened? -1. Now ground state only 1 unpaired electron +1. In the first excitation state 3 unpaired electron +3. Second excitation state 5 unpaired electron +5. Third excitation state 7 unpaired electron +7. So that's why -1, +1, +3, +5, +7. So these are the oxidation state. The next one what happened? Atomic radius. What is the atomic radius? Atomic radius that from top to bottom, like fluorine, chlorine, bromine, iodine. From top to bottom, atomic number increases. When atomic number increases, atomic weight also increases from top to bottom. That's why from fluorine to iodine, atomic number increases. Atomic weight also increases. The meaning what happened? the differentiating electrons enters into next higher energy cell, suggesting it has less predominant beyond of chlorine. So this is due to screening effect by inner d orbital. This is due to screening effect by inner d orbital. Next, electronegativity. What is the definition of electronegativity? The tendency of an atom to attract two shared pair of electrons, and it is a diatomic molecule, are called electronegativity. These halogens are high electronegativity nature. High electronegativity nature. Fluorine, chlorine, bromine, iodine. Electronegativity top to bottom are decreases. So that's, I will give a good technique this one. Fluorine, F means 4. Chlorine, 3 letters, C, that's a 3. Bromine, B, 2.8. Iodine is 2.5. So that's why electronegativity top to bottom are decreases. Physical state. Chlorine is the gases, bromine is the liquid, iodine is the solid. Interhalogen compound. Basically, what is the definition of interhalogen compound? The two halogen atoms, they react with each other. That's the interhalogen compound. These are 4 types: AX, AX3, AX5, AX7. AX means 1 unpaired electrons, ground state, sp3. AX3 means 3 unpaired electrons, sp3d. AX5 means 5 unpaired electrons, sp3d2. This is sp3d3. Linear, bent to T-shaped, square pyramidal, and what happened? Trigonal bipyramidal. So this is interhalogen compound. Then so after this interhalogen compound, chemical reactivity is there, and oxy-ice of chlorine. What is the chlorine? What is the fluorine? To be continue on next class. Okay. So this is today's topic.